Hello students, how are you? I hope all of you are fine and healthy. Welcome back to my channel Arya Bhatt Academy. Today we will learn about the basic concepts of fractions and percentage and do practice by solving different types of real-life problems involving fractions and percentage. So, let us begin. Dear students, today we will be finding equivalent fractions, writing fractions as percentages, writing percentages as fractions, and then we will be doing lots of practice by solving different types of problems involving fractions and percentage. Dear students, do you think the two fractions shown in the figure number 1 and figure number 2 are equivalent? See, in the first figure, it is 4 fractions out of total 12 fractions, which can be written as ratio of 4 by 12, which can be simplified to 1 upon 3, while, in the second figure, it is 2 fractions out of 8, which can be written as ratio of 2 by 8, which can be simplified to 1 upon 4, therefore, the two fractions are not equivalent. Equivalent fractions, the fractions are considered to be equivalent, when they have the same value, even when their numerators and denominators are different. For example, 2 upon 5 and 14 upon 35 are equivalent fractions. Finding equivalent fractions, think of a number that can be multiplied to or can divide both the numerator and denominator of the first fraction. If the resulting fraction matches the second fraction, then they are equivalent fractions. Here, there are two fractions given as 2 upon 6 and 4 upon 12. When we multiply both the numerator and denominator of the first fraction 2 upon 6 by 2, we get 4 upon 12, which is equal to the second fraction. Since the resulting fraction matches the second fraction, it means that 2 upon 6 and 4 upon 12 are equivalent fractions. Finding equivalent fractions, we have learnt that to find equivalent fractions, we have to multiply or divide both the numerator and denominator by the same number. Let us take another fraction 2 upon 8, and first we multiply both the numerator and denominator by 2, to get another fraction as 4 upon 16. So, we have found equivalent fraction for 2 upon 8 as 4 upon 16, similarly, we also divide both the numerator and denominator of 2 upon 8 by 2, to get another fraction as 1 upon 4. Hence, we have found another equivalent fraction for 2 upon 8 as 1 upon 4. The word percent is an abbreviation of the Latin word percentum, which means per hundred. Thus, the term percent means per hundred or for every 100. When we say a boy scored 95% marks in his examination, it means that he obtained 95 marks out of every 100 marks. He might have got 570 marks out of 600 marks, or he might have scored 665 marks out of 700 marks. In both the cases we can say that he scored 95% marks. Similarly, a person gave 30% of his income as income tax, means that he gave rupees 30 for every 100 rupees of his income as income tax. He might have actually given rupees 1,50,000 as income tax for his annual income of rupees 5 lakh. Hence, any fraction can be written as a percentage by finding its equivalent, that has a denominator of 100. Percentage is generally used to help in data analysis and comparison of data. As it is difficult to compare the fractions whose denominators are different, so by converting these fractions to percentage we are making their denominator same as equal to 100, then it becomes simpler to compare them. Writing fractions as percentages, there are two ways of writing fractions as percentages. In the first method, as shown in first yellow-colored figure, we have to represent the fraction in the form of shaded squares upon total squares. Here we have taken fraction 1 upon 4, which has to be converted to percent form. In the first step, we have shown it as one shaded square inside total 4 squares. In the second step we split the squares further to get total of 100 squares, keeping the same 1/4 shaded portion. Now let us count the number of squares in the shaded part in the second blue-colored figure. So, we can write the fraction as 25 upon 100. In the third step, we drop the denominator 100 and add a symbol of percent. Hence, we can write it as 25%. In the second method, in the first step, we write fraction as x divided by y form. In the second step, we multiply the fraction by 100 to get x upon y into 100. In the third step, we solve the fraction and put percent symbol. For example, in the above case for the fraction of 1 upon 4, we multiply it by 100 to get 100 divided by 4. Solving it, and putting percent symbol, we get 25%. Writing percentages as fractions, here, in the first step remove the percent symbol, and add 100 in the denominator, keeping the same number in the numerator. The fraction can then be written in simplest form by dividing numerator and denominator by their highest common factor. Here, we have to convert 60% into fraction form. So, in the first step remove the percent symbol, and add 100 in the denominator, while keeping the number 60 in the numerator, to get the fraction as 60 divided by 100. Which can be simplified by dividing numerator and denominator by their highest common factor, which is 20, to get the fraction of 3 divided by 5. Writing percentages as fractions, in the first step, we remove the percent symbol, add 100 in the denominator, while keeping the number 60 in the numerator, to get the fraction as 60 divided by 100. Then we divide numerator and denominator by highest common factor, which is 20, to get fraction as 3 upon 5. Let us understand how to find the highest common factor of the numbers 60 and 100. We first find prime factors of 60 and 100. The factors of 60 are 2 raised to 2 into 3 raised to 1 into 5 raised to 1. Similarly, the factors of 100 are 2 raised to 2 into 3 raised to 0 into 5 raised to 2. As in the case of highest common factor, we have to consider the least power of the factors. Therefore, highest common factor of 60 and 100 is equal to 2 raised to 2 into 3 raised to 0 into 5 raised to 1, which comes to 20. Dear students, here the value of 3 raised to 0 is equal to 1 only. Now, dividing numerator and denominator by their highest common factor, of 20, we get the simplified form of the fraction as 3 upon 5. Dear students, let us do some practice. In the question A, we have to write the fractions shown in Figure 1 and Figure 2 as percentage. And, in the question B, we have to write the percentages as shown in Figure 1 and Figure 2 as fractions. Dear students, pause the video, take out your rough notebook and try to solve these questions A and B, before going to next slide. Dear students, I hope you must have attempted these questions. Now, let us see whether your answers match to ours. Answer to question A, in the Figure 1, there are 10 rows of equal size in total, and out of these 3 rows are shaded. So, we can write this as fraction 3 upon 10. In the second step we can multiply both the numerator and denominator by 10, so as to get 100 in the denominator. Now, in the numerator we have 30, and it is 100 in the denominator. So, we can drop 100 in the denominator and add the percent symbol to get 30%. As percent means per hundred, so, here it is 30 fractions per 100 fractions, in the Figure 2. There is one circle, which is divided into 5 equal parts, and out of these, one part is shaded. So, we can write this as fraction 1 upon 5. In the second step we can multiply both the numerator and denominator by 20, so, as to get 100 in the denominator. Now, in the numerator we have 20, and it is 100 in the denominator. So, we can drop 100 in the denominator and add the percent symbol to get 20%. Answer to question B, in the Figure 1, we have to write 12% as fraction of 100. So, we can draw 100 squares of equal size and then shade the first 12 squares, as shown in the adjacent figure. Now, in the second step, we can drop the percentage symbol and instead divide 12 by 100, to get fraction of 12 upon 100. This fraction can be further simplified by dividing both the numerator and denominator by 4 to get the fraction of 3 divided by 25. In the Figure 2, we have to write 15% as fraction of 100. So, we can draw 100 squares of equal size and then shade the first 15 squares, as we did in the first question. Now, in the second step, we can drop the percentage symbol and instead divide 15 by 100, to get fraction of 15 upon 100. this fraction can be further simplified by dividing both the numerator and denominator by 5 to get the fraction of 3 divided by 20. Dear students, to consolidate our command over this topic of fractions and percentage, let us do further practice and solve some more examples. Before starting to solve any question, it is very important to first understand the question thoroughly. So, you are requested to first read the entire question with full concentration, understand it, then only start to solve it. Here, in the example number 1, it is given that Ash had total of 24 pages to write. By evening, he had completed 25% of his work. Then, we have to find out how many pages were left before the completion of his work. Let us try to solve this example number 1. Solution to example number 1, it is given that Ash has to write a total of 24 pages, which we can consider equal to 100% of work. By evening, Ash had completed 25% of his work, which means the work left out in percent is equal to 100% minus 25%, which is equal to 75%. So, we can write if 100% of the work is equal to 24 pages, then, by using unitary method, we can write 1% of the work will be equal to 24 pages divided by 100, therefore, 75% of work will be equal to 24 pages. Divided by 100, multiplied by 75, which comes to 18 pages, hence, Ash has still to write 18 pages to complete the work. Let us now go to second example. Dear students, I hope you are able to understand the explanation given against each of these examples. You are requested to keep a rough notebook to do all the calculations on it. Because you need to do practice to have a command over any topic, especially in maths. I would also suggest to pause the video in between, read each of the question carefully, understand it and then try to solve each of them on your own. If you are stuck up somewhere then only, refer to the solution given in the next slide. In the example number 2, it is given that one box contains 60 eggs. Out of the total, 16 into 2 by 3% are found rotten ones. Then, we have to find how many eggs are rotten. Let us try to solve this example number 2. Solution to example number 2, it is given that 16 into 2 by 3% eggs were found to be rotten in the box, which can be simplified to be equal to 50 upon 3% of the total eggs. It is given that there are in total 60 eggs in the box, which can be considered as equal to 100%, so, we can write 100% of the eggs to be equal to 60 eggs, then, by using unitary method, we can write 1% of the eggs will be equal to 60 divided by 100. Hence, 50 divided by 3% of the rotten eggs will be equal to 60 divided by 100, into 50 divided by 3, which comes to 10, therefore, there are 10 rotten eggs in the box. Let us go to third example. In example number 3, it is given that Aman obtained 410 marks out of 500 in CBSE 12th examination, while his brother Anish got 536 marks out of 600 in 9th class examination. Then, we have to find whose performance is better. Solution to example number 3, it is given that Aman obtained 410 marks out of 500, whereas Anish got 536 marks out of 600. As we have to find whose performance is better, but the denominator is not equal, so to compare first we will calculate the percentage of marks obtained by both. As Aman obtained 410 marks out of 500, the ratio of 410 divided by 500 can be converted to percent by multiplying it by 100. Solving it we get 410 divided by 500 into 100 is equal to 82%. Similarly, as Anish got 536 marks out of 600. The ratio 536 divided by 600 can be converted to percent by multiplying it by 100. Solving it we get 536 divided by 600 into 100 is equal to 89.33%. Hence, we see that Anish has performed better than Aman. Let us now go to fourth example. In example number 4, it is given that, in an orchard, 16 into 2 by 3% of trees are apple trees. If the number of trees in orchard is 240. Then, we have to find the number of other types of trees in the orchard. Let us try to solve this example number 4. Solution to example number 4, it is given that the total number of trees in orchard is 240, in which 16 into 2 by 3% of trees are apple trees. So, let us first convert 16 into 2 by 3 from percent to the number of apple trees. Simplifying 16 into 2 by 3%, we get 16 into 3 plus 2 divided by 3, which is equal to 50 divided by 3%, therefore, 50 divided by 3% of total 240 trees can be calculated as equal to 50 divided by 3 into 240 divided by 100, which comes to 40, hence, there are 40 number of apple trees in the orchard, as the total number of trees is equal to 240, therefore, the number of other types of trees in the orchard is equal to the difference between 240 minus 40, which comes to 200. Let us now go to example number 5. In example number 5, it is given that Ram studying in 6th standard obtained 553 marks out of 700 in science subject, and his sister Geeta, in 8th standard got 486 marks out of 600 in the science subject. Then find whose performance is better. Let us try to solve this example number 5. Solution to example number 5, it is given that Ram scored 553 marks out of 700, whereas Geeta scored 486 marks out of 600. As we have to find whose performance is better, but the denominator is not equal, so to compare first we will calculate the percentage of marks obtained by both. As Ram obtained 553 marks out of 700, the ratio 553 divided by 700 can be converted to percent by multiplying it by 100. Solving it we get 553 divided by 700 into 100 is equal to 79%. Similarly, Geeta got 486 marks out of 600. The ratio 486 divided by 600 can be converted to percent by multiplying it by 100. Solving it we get 486 divided by 600 into 100 is equal to 81%. Hence, we see here that Geeta has performed better than Ram. Let us now go to example number 6. Dear students, I hope you are able to understand the explanation given against each of these examples. You are requested to keep a rough notebook to do all the calculations on it, because you need to do practice to have a command over any topic, especially in maths. I would also suggest to pause the video in between, read each of the question carefully, understand it, and then try to solve each of them on your own. If you are stuck up somewhere, then only refer to the solution given in the next slide. In example number 6, it is given that Mr. Bhatt saves 28% of his monthly income. If he saves rupees 840 per month, then find his monthly income. Let us try to solve this example number 6. Solution to example number 6, let us assume that the monthly income of Mr. Bhatt is rupees Y. Now, it is given that he saves 28% of his monthly income. Therefore, we can calculate 28% of rupees Y as equal to 28 divided by 100 into Y, which is equal to 0.28 Y. Let us write it as equation number 1. It is also given that he saves rupees 840 per month, hence this amount can be equated with 0.28 Y calculated in equation number 1. So, we can write as 0.28 Y is equal to rupees 840, hence, Y is equal to 840 divided by 0.28, which comes to rupees 3,000. Therefore, the monthly income of Mr. Bhatt is rupees 3,000. Let us now go to example number 7. In example number 7, it is given that in an examination, 8% of the students failed. Then find what percentage of students passed. If total of 1,650 students appeared in the examination, how many of them passed? Let us try to solve this example number 7. Solution to example number 7, it is given that in an examination, 8% of the students failed, as the total number of students who appeared for the examination can be considered to be equal to 100%. Therefore, the percentage of students passed can be calculated as equal to difference between total number of students, which is 100% minus the number of students who failed, which is 8%, which comes to 92%. It is also given that total of 1,650 students appeared in the examination. Hence, 100% can be considered to be equal to 1650, then, using unitary method we can write that 1% will be equal to 1650 divided by 100, therefore, 92% of the total number of students who passed will be equal to 1650 divided by 100 into 92, which comes to 1518, hence, out of total 1650 students, who appeared for the exam, 1518. Number of students passed. Let us now go to example number 8. In example number 8 it is given that in an examination, 92% of the students passed and 46 failed. Then find how many students appeared in the examination. Let us try to solve this example number 8. Solution to example number 8, it is given that in an examination, 92% of the students passed. It means that total students, which is 100% minus 92% students, who passed, will be the total number of students who failed, which comes to 8%. It is also given that 46 number of students failed. So, we can equate 8% to be equal to 46. Then using unitary method we can write 1% to be equal to 46 divided by 8. Therefore, 100% will be equal to 46 divided by 8 into 100, which comes to 575. Therefore, in total 575 students appeared in the examination. Let us now go to example number 9. In example number 9, it is given that a garden has 2,000 trees in total. 12% of these are mango trees, 18% are lemon trees and the rest are the orange trees. Then we have to find the number of orange trees in the garden. Let us try to solve this example number 9. Solution to example number 9, it is given that a garden has 2,000 trees in total. 12% of these are mango trees, 18% are lemon trees and the rest are the orange trees. Then, we have to find the number of orange trees in the garden, as the total number of trees can be considered to be equal to 100%. Therefore, number of orange trees will be equal to total number of trees minus mango plus lemon trees, hence, orange trees in percent will be equal to 100 minus 12 plus 18, which comes equal to 70%, now, as the total number of trees is equal to 2,000. So, we can write 100% to be equal to 2,000 number of trees. Using unitary method, we can write, then, 1% will be equal to 2,000 divided by 100, which is equal to 20 number of trees, therefore, 70% of orange trees will be equal to 20 into 70, which comes to 1,400 number of trees, hence, there are 1,400 number of orange trees in the garden, which is 70% of the total number of trees. Let us now go to example number 10. Dear students, I hope you are able to understand the explanation given against each of these examples. You are requested to keep a rough notebook to do all the calculations on it. Because you need to do practice to have a command over any topic, especially in maths. I would also suggest to pause the video in between, read each of the question carefully, understand it and then try to solve each of them on your own. If you are stuck up somewhere, then only refer to the solution given in the next slide. In this example number 10, it is given that a balanced diet should contain 12% of proteins, 25% of fats and 63% of carbohydrates. If a child needs 2,600 calories in his food daily, then find in calories the amount of each of these in his daily food intake. Let us try to solve this example number 10. Solution to example number 10, it is given that a balanced diet, which contains 12% of proteins, 25% of fats and 63% of carbohydrates, should fulfill a child's need of 2,600 calories in his daily food. Therefore, we can write as 12% of proteins plus 25% of fats plus 63% of carbohydrates to be providing 2,600 calories of energy to the child daily, hence, 100% of. Balanced diet, consisting of 12% of proteins plus 25% of fats plus 63% of carbohydrates will provide 2,600 calories, using unitary method. We can write 1% of balanced diet, consisting of 12% of proteins plus 25% of fats plus 63% of carbohydrates will provide 2,600 divided by 100, which comes to 26 calories. Therefore, 12% of proteins, will be providing 26 into 12, which comes to 312 calories. Similarly, 25% of fat will be providing 26 into 25, which comes to 650 calories, and 63% of carbohydrates will be providing 26 into 63, which comes to 1638 calories. We can also cross-check by adding the individual calories from proteins as 312 plus calories from fats as 650 plus calories from carbohydrates as 1638, which comes to 2600 calories and matches to the total calories given. Hence our answer is correct. Let us now go to example number 11. In example number 11, it is given that Radha earns 22% of her investment. If she earns rupees 187, then how much did she invest? If she increases her investment by 10%, then what will be her earning? Let us try to solve this example number 11. Solution to example number 11, it is given that Radha earns 22% of her investment, which is equal to rupees 187. That means if she has invested rupees 100, then she earned rupees 22. This can also be written as, she earns rupees 22 on an investment of rupees 100. Using unitary method, we can write, she will earn rupees 1 on an investment of rupees 100 divided by 22, therefore, she will earn rupees 187 on an investment of rupees 100 divided by 22 into 187, which is equal to 100 into 187, divided by 22, which comes to rupees 850. Hence, she had invested rupees 850 to earn rupees 187. Now, if she increases her investment by 10%, then her investment will become equal to rupees 850 plus 10 divided by 100 into rupees 850, which is equal to rupees 850 plus rupees 85, which comes to rupees 935. Now, on the investment of rupees 935, she will earn at the rate of 22%, which is equal to 22 divided by 100, into 935, which comes to rupees 205 and 70 paisa. Let us now go to example number 12. In example number 12, it is given that a cricketer hits 120 runs in 150 balls during a test match. 20% of runs came in sixes, 30% in fours, 25% in twos and the rest in singles. How many runs did he score in A. Sixes, B. Fours, C. Twos, D. Singles? What percent of his shots were scoring ones? Let us try to solve this example number 12. Solution to example number 12, it is given that a cricketer hits 120 runs, in which 20% of runs came in sixes, 30% in fours, 25% in twos and the rest in singles. We can calculate that the rest 25% of the runs came in singles. As he hit a total of 120 runs, it can be considered as 100%, therefore, we can write, 100% is equal to 120 runs. Using unitary method, we can write, 1% will be equal to 120 divided by 100, which comes to 1.2 runs, hence, 20% runs in sixes is equal to 1.2 into 20, which comes to 24 runs, which he hit in 4 shots. Similarly, 30% runs in fours is equal to 1.2 into 30, which comes to 36 runs, which he hit in 9 shots. Similarly, 25% runs in twos is equal to 1.2 into 25, which comes to 30 runs, which he hit in 15 shots, and rest 25% runs in singles is equal to 1.2 into 25, which comes to 30 runs, which he hit in 30 shots. Therefore, in total he hit 58 shots, out of which he hit 30 shots, to score ones, which can be converted to percent as equal to 30 divided by 58 into 100, which comes to 51.72%. Let us go to example number 13. In example number 13, it is given that an alloy of tin and copper consists of 15 parts of tin and 105 parts of copper. Then we have to find the percentage of copper in the alloy. Let us try to solve this example number 13. Solution to example number 13, it is given that an alloy of tin and copper consists of 15 parts of tin and 105 parts of copper. The alloy consists of 15 parts tin plus 105 parts copper is equal to total 120 parts, which can be considered as 100%, therefore, percentage of copper in alloy can be calculated as equal to 105 parts divided by 120 parts into 100, which is equal to 87.5%. Similarly, percentage of tin in alloy can be calculated as equal to 15 parts divided by 120 parts into 100 is equal to 12.5%. We can also cross-check by adding the percentages of both the alloys, which is equal to 87.5% plus 12.5%, which is equal to 100%. Let us go to example number 14. In example number 14, it is given that a school has 300 students, 142 of whom are boys. It has 30 teachers, 12 of whom are gents. Then what percent of the total number of students and teachers in the school is female? Let us try to solve this example number 14. Solution to example number 14, it is given that a school has 300 students, 142 of whom are boys. It has 30 teachers, 12 of whom are gents. The number of girls in the school is equal to total number of students, 300 minus 142 number of boys, which comes to 158, and the number of female teachers in the school is equal to total number of teachers, that is 30, minus 12 number of male teachers, which comes to 18, therefore, total number of females in the school is equal to 158 girl students plus 18 female teachers, which comes to 176. Total number of students and teachers in the school is equal to 300 students plus 30 teachers, which comes to 330, therefore, total number of female students and teachers in the school in percent is equal to 176 divided by 330 into 100, which is equal to 160 divided by 3, which comes to 53.33%. Let us go to example number 15. In example number 15, it is given that rupees 3,500 is to be distributed among 3 persons, such that the first person gets 50% of the second person, who in turn gets 50% of the third person. Then find out how much will each of them get. Let us try to solve this example number 15. Solution to example number 15, it is given that rupees 3,500 is to be distributed among 3 persons. The first person gets 50% of the second, who in turn gets 50% of the third. Let us assume that the third person gets rupees Y, then, the second person will get 50% of Y, which is equal to 50 divided by 100 into Y, which is equal to rupees 0.5 Y, and the first person will get 50% of 0.5 Y, which is equal to 50 divided by 100 into 0.5 Y, which is equal to rupees 0.25 Y. As the total of all the 3 persons should be equal to rupees 3,500. Therefore, we can write the equation as rupees 0.25 Y plus rupees 0.5 Y plus rupees Y should be equal to rupees 3,500. Solving the equation, we get rupees 1.75 Y is equal to rupees 3,500. Therefore, we get the value of Y equal to rupees 3,500 divided by 1.75, which comes to rupees 2,000. Hence, the first person will get his share equal to rupees 0.25 Y, which is equal to 0.25 into rupees 2,000, which is equal to rupees 500. Second person will get his share equal to rupees 0.5 Y is equal to 0.5 into rupees 2,000, which is equal to rupees 1,000, and third person will get his share equal to rupees Y, which is equal to rupees 2,000. Let us go to example number 16. In example number 16, it is given that the value of a machine depreciates every year by 5%. If the present value of the machine is rupees 1 lakh, then what will be its value after 2 years? Let us try to solve this example number 16. Solution to example number 16, it is given that the value of a machine depreciates every year by 5%. If the present value of the machine is rupees 1 lakh, then we have to find what will be its value after 2 years. First of all, we have to find 5% of its present value of rupees 1 lakh, which can be calculated as equal to 5 divided by 100 into rupees 1 lakh, which comes to rupees 5,000, as the value of machine depreciates every year by 5%, therefore, after 1 year, its value will be rupees 1 lakh minus rupees 5,000, which comes to rupees 95,000. Next year the depreciation of 5% will be on rupees 95,000. Which can be calculated as equal to 5 divided by 100 into rupees 95,000, which comes to rupees 4,750. Therefore, after 2 years, its value will become equal to rupees 95,000 minus rupees 4,750, which comes to rupees 90,250. Thanks for watching. If you have found this video useful, then please like it and share it with your friends and classmates. Please do subscribe to my channel and also press the bell icon, so that you get the notification for my next video. See you all in the next video. Until then, stay fit and healthy and keep practicing.